Today we are going to do section 1.5, which is going to be the basic introduction to angles for ourselves. And I'm sure most of you already know what an angle is. If we draw an angle right now, it kind of looks like a mouth opening up, or like almost a slice of pizza. And an angle normally has some labels on it, so we can have A on our vertex, B on one side, and C on the other side. In fact, an angle is formed when two rays join at the same vertex, and the rays are called the side. And so our vertex, just like polygons, is going to be right here at the letter A, and then these two, B and C, are going to be called our sides. All right, so naming angles is pretty straightforward. We can call this angle A, and that's going to be based off of our vertex. We can also call it angle BAC. Right, so we're going B to A to C, just like you would see the angle. Or you can call it angle CAB. So we're going C to A to B. Notice that on both of these, there vertex is in the center. So if you're going to use 3 points to name an angle, which you will do quite a bit, you need to put the vertex in the center. And then finally, you can have a number in between the two sides. So we can also call this angle number 1. So we can base it off of number. And then all angles have what is called an interior and an exterior. And the interior is going to be the bit that is in between the two sides. So that is going to be right here in yellow. And I will actually grab a highlighter and highlight that in yellow. So there is going to be the interior of our angle. And then the exterior is going to be everything outside of the angle, so all of this space, all out here and forever. So the exterior of the angle is much larger than the interior of the angle. And so if we go ahead and draw a set of angles here, and so we're going to draw something that looks like this, and then we're also going to put another opposite ray, or not opposite ray, just a regular ray down the center. Our common vertex is going to be the point M, and then each one of these sides is going to be called J, K, and L. And I want to identify 3 different angles on this shape here. So we can first do angle JMK right there. So that's going to be angle JMK there in yellow. In orange, we can have this, in orange, we can have this larger angle right here. Well, that's probably the same size, but either way, we can have that other angle, and that's going to be angle KML. Notice that M is still our vertex. Or now in red, we can have this entire bit right here. And I don't want to highlight that because it's going to cover up our other colors, but that's going to be angle J to M over to L. All right, and I do want to remind ourselves about what postulates are. Remember that a postulate is a rule that we do not need to prove. And our postulate 1.3 is going to be our protractor postulate. And the protractor postulate is a really kind of simple postulate, and that is saying that an angle can be measured using a protractor. So a protractor is kind of like a half circle with some angle measurement tools on it, and it will measure between 0 degrees and 180 degrees. And so we would say that the measurement of angle ABC, we would write that as M of ABC. So if you ever see angle ABC with an M in front of it, that means the measurement of angle ABC. And I just said this protractor postulate says that we can have angles between 0 and 180 degrees. So let's look at those different types of angles. And you're probably already familiar with a couple of them, or maybe all of them, but our first type is going to be acute angles. And so an acute angle is going to be measured between 0 and 90 degrees. And how I remember acute angles is that they're acute little baby angles. I know it's a corny joke, but that's how I always remembered what they were. Next, we can have right angles, and all right angles are 90 degrees. Next, we can have obtuse angles, and I like to remember obtuse angles because it kind of looks like the word obese, and obese means fat, so these are our fat angles. And they're between 90 degrees and 180 degrees. And then finally, we can have straight angles, and those are going to just be our lines, because technically these have a measurement of 180 degrees. So this is 180 degree measurements. And then just like how two segments can be congruent, angles can also be congruent. So two angles are congruent. When they have the same measurements. And so we would say that the measure of angle A would be equal to the measure of angle D. And if the measurements are equal, we would write that angle A is congruent to angle D. Remember, the equal sign with a little squiggly above it means congruent to. And so just to really hammer this idea home, we're going to draw a quadrilateral over here. And this quadrilateral is going to be E, F, G, and H. And then we're also going to draw another quadrilateral over here. This one's going to be a little bit different. And this guy is going to be called A, B, C, and D. And here's what we know. This G and this B have a single dash, and this D and this F have a double line. And so first question is, which angles are congruent? And so the same properties with congruent segments with little tick marks apply to angles. A single arc correlates to a single arc. So angle G is going to be congruent to angle B. And then angle D is going to be congruent to angle F. And then if I told you that angle ADC is equal to 140 degrees, can you tell me what the measurement of angle HFG is? Not HFG. Sorry, that doesn't exist. EFG. Well, since EFG is going to be this angle right here, and ADC is this angle right here, we know that angle D and angle F are congruent. So this is going to be equal to 140 degrees. And now the cool thing about angles is that if you have two angles next to each other, you can actually add their measurements up to find a larger angle. And so that's going to be called the angle addition postulate. So if I draw here a series of angles, and we have a common vertex S, and then we have R, P, and T. In red here, I'm going to highlight what the measurement of angle RSP is. And then in green over here, I'm going to highlight what the measurement of angle PST is. And so if we wanted to find the measurement of RST, we would actually need to add the other two angles together. And so the measurement of angle RSP, the red bit, plus the measurement of PST, the green bit, is going to be equal to the measurement of RST, the blue bit. So you can add angle measurements together. And so now let's apply this in a more algebraic sense. This is going to have a common vertex of K. This left side is going to be L. This middle side is going to be M. And this right side is not going to be R. It's going to be N. And then LKM is equal to 2x plus 10 degrees. And then MKN is going to be equal to 4x minus 3 degrees. And I want to find the measurements of angles LKM and the measurement of angle MKN. And we are given the fact that angle LKN is equal to 140 degrees. So from here all the way to here is equal to 140 degrees. Sorry, 145 degrees. And so all we need to do is set up our angle addition. So we know that the measurement of LKM, which is going to be this angle right there, plus the measurement of angle MKN, which is this angle right here, is going to equal the entire measurement of 145 degrees, LKM. And now we just need to substitute what we know for LKM and MKN, those two blue algebraic expressions, into this formula and solve for x. So we're going to have 2x plus 10 plus 4x minus 3 is equal to 145 degrees. And so let's first combine like terms. 2x plus a 4x is going to be a 6x. 10 minus 3 is a positive 7. Is equal to 145. We need to now subtract 7 from both sides, so we're going to get 6x is equal to 138. And then we're going to divide both sides by 6 to get an x is equal to 23. Now, this is not our answer. This is only a tool to get to our answer. Our final goal is to find the measurements of LKM and the measurements of MKN. So we need to substitute x is equal to 23 into both angles. So the measurement of angle LKM is going to be equal to 2 times our 23 plus a 10. And 2 times 23 is 46 plus 10, which is going to be equal to 56 degrees. Now you have one of two options. You could take 145 minus 56 to get 89, or you can say that the measurement of angle MKN is equal to 4 times 23 minus 3. And 4 times 23 is going to be equal to 92 minus 3, which is equal to 89 degrees. And if we add 56 and 89 together, we should get 145 degrees. Finally, let's talk about bisecting angles. So just like how we can bisect a segment into two congruent segments, we can also bisect an angle into two congruent angles. So if I draw this angle out right here, and then draw this red bit going straight down the center, this red ray is going to cut this blue angle into two congruent angles so that left and right are equal to each other. So if I throw some labels on here with a common vertex y, top is x, bottom is z, and our new bisector is w, we would say that ray YW bisects the blue angle XYZ. And now the two resulting angles, angle XYW and angle WY and Z, those are going to be congruent to one another. Basically, if you see the little hash marks, that means they're going to be congruent to one another. So now let's find the measurement of angle QPR, and it'd probably be nice to see where QPR is. That's completely wrong, by the way. We need PQR. So here is our setup here. Our common vertex is going to be Q, top is going to be P, middle is going to be S, the bottom is going to be R, and we know that QS is an angle bisector of this guy. And so PQS we're given to be 24 degrees. And we know that the measurement of angle PQR, this larger one, is going to be equal to the two smaller angles added together. So that's going to be the measurement of PQS plus the measurement of SPQ. And now we also know that this is 24 and this also has to be 24. So this is going to be 24 degrees plus 24 degrees, which is going to be equal to 48 degrees. So that's all I have for you today. That's our basic introduction to angles. If you have any questions, please let me know.